class. This is A1 in 8th grade. I don't remember where it is in the other class for 7th Accelerated, but this is defining a linear function rule. So we're defining a rule. Rule really means write an equation for a situation. So let's look at a couple different things. Let's start with remembering that when we say linear, that really means it forms a line when you graph. So you got to make sure you know what linear is. So it forms your equation, your function. So equation or function, function's graph is a line. I like saying it's linear, so linear. So let's say we're looking at a couple different things that are graphs, and then it's going to ask you, is it linear, is it not? So there's a couple ways we could do that. So let's start with, what if I have y equals 2x and y equals x squared? Which one is linear and which one is not linear? Well, the hint is you always just have an x. You can times it, you can add it. So it can be like 3x plus 4. It can be 1/2 x minus 7. It can be lots of different things, but it cannot be an x squared. And let me show you why. So let's make charts and graph these two. We'll also show you how to graph them on a calculator. So here we are. We have those two, right? And I'm going to do this one first. Let's put in 0. 0 times 2 is 0. Let's put in 1. 1 times 2 is 2. Let's put in 2. 2 times 2 is 4. Let's put in a negative so we know what it does on that negative side also. So let's put in -1. Oops, I gotta move this over a little. My mouse is in the way. Okay, so let's put in -1. -1 times 2 is -2. Now for the other one, same kind of idea, let's put in 0. Well, 0 squared is 0. Let's put in 1. 1 squared is 1. Let's put in 2. 2 squared is 4. Let's put in a negative here too. -1. What is -1 squared? Well, be careful how you enter that in your calculator. Let's think about that. You are squaring that -1. So this is a graphing. You could have a basic one. Mine broke, and then someone stole my other one. So this is what I have. So I was showing you -1. If I hit the negative button, which is down here, whoop, and if you have a different TI, it looks the same. So negative, and you have to use that 1 to the second power. Well, it gives me -1. That's not right, because what this is saying is, okay, square the 1 and make it a negative. You have to use a parenthesis if you want to show that you're squaring that whole number. This is why most people mess up squares. We know -1 times -1 is +1. So be careful. Don't use your calculator without the parenthesis when you're putting a number in for a square. Now, if this had a negative out front, totally different problem. It's just like this one. You're squaring it and then making it negative. So if it's just an x squared and you're putting a number in, you better get a positive answer. So let's do it for -2. -2 times -2, that's what square means, is +4. So -2 squared is +4. Now let's graph these two and see what we got. All right, so this first one, we have 0, 0. We have 1, 2. We have 2, 4. See that pattern of up 2 over 1, up 2 over 1 for that slope? And then we did a negative, -1, -2. See, up 2 over 1, up 2 over 1, that's our slope, and definitely forms a line. And so this is our linear function. Yay! And this one was y equals 2x. And now let's graph our other points, and I'm pretty sure I had another color over here somewhere. Or I used to. Oh, yep, here's my red one. Okay, so we have 0, 0. We have 1, 1. 2, 4. Negative 1, 1. That one doesn't look real covered. Negative 2, 4. 1, 2, 3, 4, yeah. Oh, I don't think I went up. I went 2, 3. This one should be up all the way up here. Not this one. Okay, negative 2, 4. All right, so you can see this definitely does not look linear. This one's a U shape, so squares make a U shape. Now, the hard thing with this is sometimes you'll make dots or you won't make enough and you won't be able to tell whether it's linear or not. So let me show you on a couple things. So first of all, the Desmos graphing calculator is amazing. No, you won't be able to use it on any tests and things like that for when you have to come to the centers and stuff, but it is amazing and you can use it to double check any of the homework. Let's put in what we had. We had y equals 2x. Look, there it is. Click down and you can enter in the other one. Y equals x, oops, squared. And you can, oops, so you can use the square here and you can see the U shape. So what I would do is do all the paperwork so I know you understand the math and you should be writing this down, not doing it in your head. And then graph them in Desmos.com, or you can graph them if you have a handheld graphing calculator and see if one's linear or not linear. Okay, but this calculator is awesome because it's super easy to see. The blue one is the blue, red is the red, and just easy to use. Okay, so let's look back at, oh, I know what else I was going to show you. So when you're in your homework, I'm in 6th grade. It doesn't matter what class. Oh, except it does matter when I'm in the B class, and that's so not going to help. Okay, so if you're in your homework and your tests, and I'm just going to click in any of the homework. It doesn't matter. This one was late. Improve my score, sure. Continue, sure, because this is clearly late. I'm just going to go into any question. There is another place that I wanted to show you to make sure you saw these. In question help, there's math tools. And in the math tools are a bunch of math tools. Let's look at the coordinate grapher. Coordinate grapher, ready, set, go. Am I missing something? No, coordinate grapher. It's like not letting me see. Oh, here we go. Oh, first quadrant, full plane. We want the full plane. Yeah, here we go. This is the full plane. And we can graph whatever we want. We can also put in textbook. I thought we had, they changed this a little bit, but we can put in, I thought we had, maybe I'm in the wrong one. Maybe this isn't as helpful as I thought it would be, huh? Number line, coordinate grapher, data, balance, algebra tiles, energy fractions, area models, place values. All right, I'll have to show this on a different video because it used to be able to put in the equation. Datas and graphs, no. Maybe it's in the datas and graphs. No, you can put in your numbers and it will graph them. Okay, so we could put in like the numbers we got, 0, 0. This is helpful because Desmos does not do this. 1, 2, 2, 4, negative 1, negative 2. I just did the line. And then I think you can graph it. Select graph type. We want to scatter plot. Okay. Minimum, maximum, minimum. Oh, let's do negative 10 to negative 10. So we're going negative 10 to 10. Okay. Step. Wait. Why is my column A? Oh. X-axis, Y. Column B. Goodness, I Still can't get that to work. I am not showing you something good. All right, I paused my video for a second because I was like, what? All I had to do was go back into scatter plot. It just wouldn't work at first because I had negatives in there. And when you first go to scatter plot, it doesn't have negatives, it has 0. So if you change those before you click OK, you can get your graph. But anyway, this is the graph. It graphs the points. And I really do like some of these tools in here and wanted to make sure I showed you them. Whether they're helpful or not. I really do like the Desmos for whether it's linear or not linear. But let's look at a couple more problems that we would see in our homework. Okay, so what if we see, let's say we see how do they do this one? Describe each linear function using the following rules. So they may show something like this. A linear function rule is an equation that describes a linear function. So they're showing like some examples of linear functions. This one is linear, right? Goes up. This one is linear, but it's not a function. The only line that's not a function is vertical. So you might want to write that in your notes. Vertical lines do not make a function. Horizontal do, but it's like we aren't allowed to get out more than one number when we put in an x value. For example, if I put in, this is 4. If I put in 4, I get out a million different answers. I can be in a bunch of spots. It's not a function. This one is a function, but it's not linear. Okay, so we had that rule where we move our pencil across, and if we hit 2 places, it's not a function. So if these two are functions, not linear, but function. This one's not a function because I have a million points on the same spot on that line. Then down here, describe each linear function using one of the following rules. So which rule represents this one, right? So look, you can make a little chart like we did. This one's where your points are the same, right? If I put in 1, I get out 1. If I put in 2, I get out 2. So 1, 1, 2, 2, 3, 3, -1, -1. This one matches this one because they're all the same. So make a little chart of these so you can see what are the answers looking like. What about this one? Okay, I'm getting out 0, 0. That's important. It means you didn't have a plus on there because you got out. If you put in 0, you got out 0. Well, this one does that. This one does that. So in that one, but we know that one goes there. So look at this one. We go 1, -1, 2, -2. So what do we notice about those 1's compared to those y's, those x's, excuse me, compared to those y's? 1's positive, 1's negative. Well, which one of these looks like it's switching your values to negative? This one, right? If I put in 1 for x, I get -1 for y. So this one matches this one. What about this one, this last one here? Well, I have 0, 0. So this one's out. 0 plus 2 is not 0. So it has to be this one or this one. Now let's look. If I put in 1, I get out 2. 1 times 2 is 2. So I put in 1, I got out 2. Has to be this one. This one actually represents a, you go to the y at 2 and you make a horizontal line. X equals a number is vertical like this one that we can kind of see here. This was x equals 4 and it was vertical. Y equals is horizontal. Pause, write that down. Y equals horizontal through that y spot, right? All of your y's are 2, so you're going through that y. X equals is vertical, and you find that x spot and you make a line because you're going through all those points. So these two match here. Okay, hint, it can't go through 0, 0 if it has a plus. Okay, so we make a chart, whatever you want to do to make that work. Let's say we have, what do they do? The function, is it linear? So they give you some and they say, is it linear or non-linear? Let's see here. Linear function rules look different from other function rules. So we know some things are functions, but we're really focusing on linear functions here. So like this one is a function, but we don't really care because it's nonlinear. So they're giving you some examples here that are linear functions. So notice there's one letter, xy, or ab, or dt, or xy again, or zy. There's two letters, there's no exponents, right? There's no x in a denominator or letter in the denominator. See how this one's in the denominator? Not a linear function. There's no squareds here. There's a square here because it's not a linear function. These are functions, but they're not linear. Absolute value, square roots, all those weird symbols that none of you really want to work with, those are making nonlinear graphs. How can I double check if something's linear or nonlinear? I make a chart and I graph it. I might need 5 or 6 points to be able to see, or I use a graphing calculator, graph it. I would love to see you write them out, and then also use the calculator to check. Okay, so let's look at these. Based off of what we just said, is a linear function? Well, we already graphed this one. No, it has a square. B, is that a linear function? Yes, it just has an x and a y or ab. I don't care what the letters are. And it's just a 4 being times. So it's actually going to go at 0, go up 4 over 1, up 4 over 1. That's our slope, 4 over 1. And C is y, so equals -3. So that one's going to go down 3 over 1, down 3 over 1. Again, linear, just an x. Is D linear? Nope, not linear because the x is in the denominator. It actually looks like this when you graph it, which is kind of hard to see on your graph unless you did lots of points. That's why you want to try to do the points, but you also probably want to use a calculator to make sure you didn't just get this half and not see this half. Okay, and then the last one, is x minus 2 a linear function? Well, yes it is. Okay, it's like taking that line down the middle, y equals x, but you have to subtract 2 and you just move it down a little. So the adding and subtracting is going to move your lines up and down. Okay, and then they show some graphs. We have already looked at that one. Definitely, you'll graph this a ton in high school, but it's not linear. All right. Let me see if there was anything else. I think that was pretty much, they made you come up with, let's look at this one because it's a word problem. A dog walker earns $10 plus, oops, where'd we go? There we go. A dog walker earns $10 plus $3 per dog. So, how would I write a function for this? Like an equation. Well, which one do I have to times by? Or how do I think of that? The dog walker earns $10. What one is a one-time thing? I get $10, right? But 3 depends on the amount of dogs per dog. That means 3 is your rate, and you have to times that 3 by something. So for that one, you would want to times the 3 by the number of dogs, and then what you have one time, you just add. And that's your function, okay? And they ask some questions, but I want you just to be able to write the function because most of you can come up with the equation. But what is your one-time thing? You add. What is the thing your per, has the word per, or that you have per, it depends on how many of something else you have. This one, it was dogs that you're walking. Yeah, and so when you go to do your homework, you are welcome to use that Desmos calculator. Again, be able to make those charts, and good luck on your homework.